For most of modern history, farmers believed that high yields required endless bags of chemical fertilizer. Nitrogen, phosphorus and potassium became the backbone of industrial agriculture. But, long before that system took over, and especially during the World War II era, when supplies were scarce and self-reliance was a necessity, growers relied on something far more powerful and far more natural living soil bacteria that made crops feed themselves. Today, that knowledge has been buried under marketing, regulations, and corporate interests. In this guide, we are going to uncover what those bacteria were, how they worked, why they disappeared from store shelves, and how you can still put their principles to work in your own soil. Why wartime farmers trusted microbes more than factories. During World War II, fertilizer factories were redirected toward explosives, ammunition, and fuel production. Farmers in Europe, Japan, and North America suddenly found themselves without reliable chemical inputs. Yet food production had to increase, not decline. The answer came from soil science that had been developing since the early 1900s. Researchers had already identified nitrogen-fixing bacteria such as Rhizobium, Azotobacter, and Azospirillum, along with phosphorus-solubilizing microbes and mycorrhizal fungi. These organisms lived around plant roots and converted atmospheric nitrogen and locked up minerals into forms crops could use. Governments quietly promoted inoculated seeds and microbe-rich compost systems. In many areas, farmers were trained to grow legumes, rotate crops, and maintain living soil. Fields treated this way produced reliable harvests without synthetic fertilizer. For wartime growers, this was not theory. It was survival. How nitrogen-fixing bacteria turned air into plant food. The most powerful of these organisms were nitrogen-fixing bacteria. Atmospheric air is almost 80% nitrogen, but plants cannot use it directly. These microbes solve that problem. Rhizobium bacteria lived inside nodules on the roots of beans, peas, clover, and alfalfa. In exchange for sugars from the plant, they converted nitrogen gas into ammonia, which fed both the host plant and the surrounding soil. After harvest, leftover roots enriched the field for the next crop. Free-living bacteria such as Azotobacter did similar work without needing legumes. They lived in healthy soil and fixed nitrogen independently, slowly building fertility year after year. A single well-managed acre using these systems could replace hundreds of pounds of chemical fertilizer annually. Wartime farmers knew that once the biology was established, the soil fed itself. When World War II ended, fertilizer factories returned to civilian production. Ammonium nitrate plants that once made bombs now made crop nutrients. Corporations invested heavily in marketing, distribution and research that promoted chemical dependency. Microbial systems, by contrast, were slow, local and difficult to patent. They required farmers to understand soil management rather than buy products. Governments favoured industrial agriculture for efficiency and export. Universities shifted research funding towards synthetic inputs. Inoculants were still available for a time, but they were treated as minor supplements rather than foundations. Over decades, many strains were lost, poorly maintained, or restricted by regulation. Today, only simplified versions remain on the commercial market, often diluted and unstable. So, chemical fertilizer, you see, feeds plants directly but ignores soil biology. Over time, this weakens microbial populations, compacts soil, and, well, reduces organic matter. Crops become dependent on increasing doses. Now, biological systems work differently. Bacteria and fungi build soil structure, store nutrients, improve water retention, and regulate plant health. They form networks that distribute minerals efficiently. Fields managed biologically during the mid-20th century often maintained fertility for decades without external inputs. Modern regenerative farms, using similar methods, are now documenting higher resilience to drought, pests, and disease. This is why old farming journals repeatedly mention self-sustaining soil. It was not romantic language. It was technical reality. Why, you might wonder, can you not buy the original bacterial systems today? The original wartime inoculants were often region-specific, freshly cultured and locally distributed. They were alive in the true sense. They required refrigeration, careful handling, and fast application. But modern retail systems are built around shelf-stable products. Living microbes do not fit easily into that model. Many strains die before reaching consumers, and, well, others are restricted under biosecurity laws. There is also, little financial incentive to promote systems that reduce repeat purchases. A healthy microbial soil reduces dependency on fertilizer, pesticides and additives. That, honestly, threatens established business models. As a result, what remains on the market is fragmented and often ineffective compared to historical standards. Although you cannot buy the exact products of the 1940s, you can rebuild similar systems with deliberate management. Begin by growing nitrogen-fixing crops such as peas, beans, clover and vetch. Inoculate seeds with high-quality rhizobium strains when possible. Allow roots to remain in the soil after harvest. Next, build microbial habitat through compost. Traditional wartime compost used layered plant waste, manure and soil. Properly matured compost contains billions of beneficial organisms. Apply it regularly around crops. Avoid excessive tillage, which destroys microbial networks. Use shallow cultivation or mulch systems instead. Feed microbes with organic matter. Leaves, straw, wood chips and kitchen scraps become fuel for bacterial and fungal populations when composted or mulched. If possible, brew aerobic compost tea using mature compost non-chlorinated water and gentle aeration. This multiplies living microbes and allows you to reintroduce them directly to soil and foliage. Across North America and Europe, small farms are rebuilding wartime-style fertility systems. They rotate legumes, integrate livestock manure, compost intensively, and minimize chemical use. Many report fertilizer reductions of 70 to 90% within 5 years. Soil tests show rising organic matter and stable nutrient levels. Yields remain competitive. Home gardeners are achieving similar results on a smaller scale. A backyard garden managed biologically can become largely self-feeding after, several seasons. The key, really, is patience. Biological fertility sort of compounds over time. Every season, it strengthens the system. Why does this knowledge matter now more than ever? Well, supply chains are fragile. Fertilizer prices, they're volatile. soil degradation is accelerating too. The wartime generation understood that food security depended on independence from external inputs. Living soil bacteria provided that independence, and honestly, they still can. By restoring these systems, you are not, copying nostalgia. You're reclaiming proven science that kept nations fed under extreme pressure. If this guide helped you understand the hidden power of soil biology and why it disappeared, do make sure to subscribe to the channel for more forgotten agricultural history and practical survival knowledge. Share this video with anyone who still believes good soil comes from a bag. Together, we can keep this knowledge alive for the next generation.